Hi, in this lecture we will see how to print the boundary nodes of a tree. So if you look at this tree, this is a sample tree which I have drawn here. If I go to the boundary nodes, I will see that 2 is coming, and if I will traverse on the left hand side, then 5 will be coming like I shown here, then 11 and 4 will be coming, 11 and 4, 17 will be coming, 9 will not coming here because 9 will be coming from the right hand side, so then 6 will be coming, then 9, then 21, 7, and 2 has already been visited, so after 7 it will stop. So basic flow will be like from this portion, then bottom, then right hand side, somewhat like that. So it is like 2, 5, 11, 2, 5, 11, 4, then 7, 6, 9, 7, 6, 9, 21, 7, that's it. So the idea behind boundary traversal is that we should first move in left hand side and go till the end. So 2, 5, 11 and 4 will be printed. Then we print the bottom most left hand side, that is this, and then bottom in the right hand side, that is 7 and 6. After this we need to go in the right hand side traversal, that is 6, 9, 21 and 7. So left, bottom right and right. These are the 4 methods only we require, which will cover all the things. So if we talk about this, then the basic condition for the boundary condition, I passed head here, so head is 2 here. So we have to check first the boundary condition is that head should not be null. So if head comes out to be null, then we will not do anything, we'll just return. So if this doesn't comes out to be null, then I'll simply print the data, that is head dot data, and let me apply a comma here so that it will, the answer should come out in this way only. And as I said, I will have to traverse left, so I will simply go print left, and for printing left direction I will pass head data in the left part. Because why left? Because already we have printed the head data, that is 2 we have already printed, so I will move head dot left, that is from 5, and now I will go in this direction, that is print right. So if I go in the print right direction, this is the print right direction, but bottom up manner, like 6, 9, 21, 7. In between I will have to print boundary, that is the bottom boundary. So first I will go with the left boundary, and then I will go right boundary. Since the boundary condition will already be printed in from left till right direction, we don't need to create one more function. It's just that we will pass the left and right subtree in this same function only. So if I pass head dot left, and similarly I will pass head dot right, both the method will be executed and data will be printed accordingly. So these are the 4 basic functions we generally require here. So I will create them one by one, create this, then this, and then this. So these are 3 functions which we require. I will mark it as root, and here also root, and here also root. So boundary condition or boundary problem for a tree is important, because in this boundary traversal we get to understand how to print all the views of a tree. So when I am going for a print left direction, so what I will do, I will try to traverse this first by checking that if root should not be null, then I will simply return. Otherwise I will check if root dot left is not equal to null, then I will go inside this and simply print out the root data. And again I said I will pass a comma here with a space to match our answer. Then I will go print left and pass root dot left data, because we are traversing in the left first, then we are going in the right. Again, if this is left is not equal to null, then we are going in the left. If left comes out to be null, then I will check whether this dot right should not be null. If this dot right is not null, I will simply print the root data and go to the right subtree. That's it. Again, I will go to the print write function. Here also similar kind of data will be required. So if root equals null, then simply return. If now, since this is a right subtree, we will have to check the rightmost part first, not the leftmost part like we did here. So I will just check root dot right should not be null. Then we will go inside this if function. Otherwise, we'll go to the else part. We'll go to the left function of a tree. That is left part. The condition for printing left was simple because we were going to print first the data, then we are going in the left subtree. That is, we were going in top to bottom. But in right subtree, we are going from right till top. That is 6, 9, 21 and 7 is coming. 6, 9, 21 and 7. That is bottom up fashion. To print data in the bottom up fashion, we should first call this. Like the function should be called first, then we should print. Unlike we were using in the left part, that is, we were using first data printing, then we are calling this function. So just the opposite we have to in the right one, that is, we have to call the function, then we have to print the data because it will be bottom up fashion. So root dot write, and we have to print after that. So root dot data and comma separated answer. Similarly, I copy this, and in the left part I will, instead of right side, I will call left. So the difference which lies here in printing left and right is that in the left part we were first checking for the left, but in the right part we were checking first for the right. Second part came out that we were printing data first and then we were calling the function, but in the right subtree we were calling the function first, then we were printing the data. This is bottom up fashion. This was top down fashion. After this, as you can see, we are complete with printing left and printing right. Now we have to go with the boundary condition. Boundary condition is just a simple one, that is if root dot data root equals null, then simply return. Otherwise, check, call this function print function, print left boundary and root dot data. Similarly, print left boundary root dot right data. Here it will be root dot left because we have to traverse the tree in the left and right, and in between we will have to check whether the node which is coming right now, that is root dot left, is a leaf node or not. If this comes out to be null and root dot right comes out to be null, then we will print the data. Root dot data, and it will be comma separated one. That's it. So data. So in this way we will print the data, and now when I will run this, run as Java application, so all the data is coming, but they are coming and in a different line. So I will just remove this whole thing here, that is the ln part, so that they should come in a line. Now we run this, so it is coming 2 5 11 4, as you can see, 2 5 11 4, then 17 6, then 11 and 5. There might be some mistake here. So as I have seen here, this is left we have passed, then in the left boundary, then we are writing past. Here should be, it should be right. Then we should pass this right subtree for the right print. Now when I will run this, as you can see, data is coming out 2 5 11 4, 2 5 11 4, then 17 6 9, 17 6 9, then 21 and 7. This was about printing a boundary view of a tree. So the thing is, pass the left subtree in the left view. It should be top down fashion, then left boundary for all leaf nodes, and then right subtree with all the leaf nodes, and then we have to print the right subtree from as a right view, but in the bottom of fashion, not in the top down. This is about how to print a boundary of a tree. Thank you all for watching the video.